Welcome back. Let's do a delta to y problem. Here's our circuit. It's a similar configuration to the circuit we've seen before in the last problem. The values are a little bit different, but the resistors are laid out in the same arrangement that we've seen in the previous problem, except now we have a ideal voltage source. This guy puts out 80 volts all the time, and it has a current through it, I. And there's some deltas in here and there's some Y's in here. So there's a delta up around the top. These three resistors are connected in a delta configuration. There's another delta over here, these three resistors. And then there's a Y between these three resistors. But there's nothing that's in simple series and there's nothing that's in simple parallel, so we have to use this delta to Y. But there's some interesting things that are going on in here. We want to find V1 and V2, and V1 is this guy. It's the voltage across the 30 ohm resistor, and V2 is this guy. It's the voltage across the 10 ohm resistor. So if I label these nodes A, B, and C, V1 is the voltage between nodes A and C, and V2 is the voltage between nodes B and C. All right, it's another way to describe V1 and V2. Let's go ahead and do the delta to Y. So we're trying to find V1 and V2, but we're asked specifically to use a delta Y transform. And we also want to use current division. Just to because these are the topics of the chapter, so we want to use these methods specifically. So I'm going to go ahead and do the delta to Y transform. I'm going to do the for ABC, for the delta ABC. Okay, so I'm going to redraw this kind of carefully so we don't get too messed up here. So let's call this node D just to have something to call this guy. So he's still there, and the 28 is still there, and B is here. This is 28 ohms up here, and I'm gonna kind of scrunch. Let's see, the 16 ohms there. So here's A, B, and I'm gonna move the C node down here so it looks a little bit more delta-like. Okay, the A, B, C delta, I'm going to draw it so that it's a little bit more looking like a triangle. I just sort of scooched over the C note a little bit. Okay, so this is, well, I don't want to go too down in the details here because, well, it'll take too long and it'll also be confusing, but if you do the delta to Y transform, okay, then the values you're going to get are you're going to get these three resistors, okay, and it's going to be 18 ohms, 6 ohms, and 3 ohms. But I'm just gonna do the delta Y EQs. Okay, and I don't want to take the time to do that, but this is going to be R sub 1, this is going to be R sub 2, this is going to be this is going to be R sub this is going to be R sub 1 because it's opposite A. This is going to be R sub 2 because it's opposite B, and this is going to be R sub 3 because it's opposite C. Actually, I said that wrong. For the delta, the R's are letters, right? So this is R sub C because it's opposite C. This is R sub B because it's opposite node B, and this is R sub A because it's opposite node A. Sorry about that. And then this is going to be R1. This is going to be R2, and this is going to be R3. But just apply those equations and do that. I don't want to kind of wander off in that area. Now, and also, because what I really want to talk about is these V's, okay, and when they change and when they don't. That's the main thing. But anyway, do the delta to y and you'll end up with this. Now, we can further simplify this, right? Because at this point, we have 28 in parallel with 6, right? So 28 is in parallel with 6, and no, series. 28 is in series with 6, and 18 is in series with 16, okay? And these two guys are in parallel with each other, right? So you could even write this as these two guys are in parallel with these two guys. And after you did that, you would end up with the result of this, plus 3, right? All of this stuff equals 20. So, what you should really do is redraw this after every transform. Like first do the series and then redraw it. Then do this series and then redraw it. And then you end up with two guys in parallel. Do that and redraw it. And then you end up with two guys in series and do that and redraw it. But this is what that would look like in just one equation. So if I go ahead and so first I did a delta to y. Then I'm gonna do some series and parallel stuff, and what you end up with after doing this stuff, you end up with this circuit right here. Okay, and the value of that is we can get I now. Okay, so V equals IR, so I equals 80 over 20. It's going to be 4 amps. Okay, so I is a useful value we're going to need later. Okay, so the point of that was just a little more practice with transformations and simplifications. First I did a delta to y, and I skipped all the math, but I'd like you to show all the math on the homework. And then I did a series or a sequence of series and parallel simplifications, and I ended up with this guy. Once again, I skipped redrawing, but you should show the math, and you should show all the circuits. Do as I say, not as I do, right? That's because I'm a teacher. We get to do that. Yeah. Anyway, the next thing we want to do is redraw one more time. Redraw the this guy above to make it look a little bit more like this. Look, so back on the original circuit, the way it's drawn, V1 is between A and C. I still have A and C in here, so V1 is right here. This is V1 between A and C, because here's node A, here's node C. There's one resistor in here. Now there's two resistors after the delta to Y transform. There's two resistors between node A and C. But V1 is still between nodes A and C. Okay, that's the main thing I wanted to kind of point out in here. That's why I'm skipping the details on these simplifications, because I really want to talk about this. But V2 likewise, V2 is between nodes B and C. So V2 is right here. So this is V2 between nodes B and C, with the positive terminals at B, the negative terminals at C for V2. Okay, so let's redraw the previous you know, to make it look like the first circuit. So I'm gonna do that. Okay, so here's the, I want it to look like this guy up here. You know, strictly speaking, you know, we could probably get this done without redoing these, without doing these drawings here, these redrawings. But I want to do that because I think there's some value in that. So C was down in here, right? So, you know, let's yeah, the 16 was A was here, right? This is A, and the 16 was here. The 16. This is the 28. A was here. Is A, and then this guy had a well, had a there's the 18. This is the 18. Then there's the 6, and then there's the 3 was in here, and they come down to node C. So it looks, this, I sort of straightened out this Y right here so that it looks a little bit more like the original. And if you want, you could pull node C off here, off to the side a little bit, just so, you know, we could see that V2 is right here. You know, V2 was sort of drawn straight up and down here, so here it is. You know, strictly speaking, don't really need this. I mean, we could do it with this, but the point is, you know, if you're not seeing it, take the time to redraw these things, because you know, that's fine, right? So V1 is between nodes A and C. Between nodes A and C, it's right here. And V2 is between nodes B and C. B and C. Okay, let's label a couple of more currents here, and then we'll be able to get V1 and V2 if we had all these currents. So we know this is I1, which, or just I. This is I, which we found out to be 4 amps, by the way, from this thing here. By the way, this was node D, and this was node C. Yeah. Anyway, so basically all of this junk right here simplified down to 20 ohms between nodes D and C, and then we could find the 4. But anyway, this I is 4. We know what it is. This one here, let's call it I1, and this one here, let's call it I2. So there's the current division thing, right? We've got this I1 coming out of the source, and it gets to node D, and it splits, it divides, right? This I current divides into I1 and I2. So we can do a kind of a fancy kind of current division. Before we do that, what's the simple kind of current division? Okay, normally, you know, current division, you've got a current coming into, you know, you've got a current I coming into this thing. Some's going to go this way and some's going to go that way, I1 and I2, right? And if you call this R1 and R2, what does current division say? I1 is going to be I1 split by something, and I2 is going to be I1 split by something. And you put the sum of R1 and R2 on the denominators of these things. And then you, for I1, you put the opposite, so you put R2 up here. And then for I2, you put the opposite, so you put R1 up here. Okay, so if I have a current coming into 2 resistors, these are the current division formulas to describe how I1 is split into these two things. It's current division for 2 resistors. What's happening? What would happen if we took this and split it into 2 guys? So if we had this come up like that, okay, it's still going to split. Right, I is going to split and go this way, and they're going to, you know, that sum's going to go that way and sum's going to go that way. That's kind of what's happening here. So, all right, so I1 is coming into here, into node D, and splitting. Some's going this way, and some's going this way. But they come back together here at node N. Let's call this node N for neutral, which would be right in here, node N, right? So once again, I1 comes into node D. It splits, and it goes through the 28 ohm, and it goes through the 6 ohm, and it comes back to node N. And the rest of I splits into I1. It goes through the 16 and the 18 and comes back in. So this current I splits and goes around, and it joins back together at N. So like, you know, sort of what I'm saying, that this is node D and this is node N. Okay? So what's that look like in math? Well, I1 is the 4 amps split by something, and I2 is the 4 amps split by something. And what are they split for? They split by, one branch has 28 plus 6, and the other branch has 16 and 18. So those are the denominators. Yeah, the branch here is 16 and 18, and the branch here is 28 and 6. And then for I1, we put this opposite side on the top, so 28 plus 6. And for I2, we put the opposite on the top, or 16 plus 28. Okay. And strangely for us, this works out to 2 amps for both of these things. And why is that? It's because I messed up, because this 28 should be an 18. 28, 6, 28, 6, 28, 6, 28, 6, 16, 18, 16, 18, 16, 18, 16, 18 on the top, 28, 6 on the, okay, yeah. 2 amps, because this is what, 34 and 34. It's 2 amps, 2 amps. So now we can solve for V1s now. So that was current division. Now we could use kind of a fancier Ohm's law kind of a thing. And V1 is given by the voltage drop across this guy and this guy, right? There's a voltage drop here because there's a current I1 traveling through this dude. And then there's a voltage drop here because there's current I, right? So once again, this is I, right? Because I1 and I2 come back around and they meet here, and then I comes back down here. So there's I through here, but there's I1 through here. And this is I2, right? So there's I2 through this 6, but I through the 3. So V1 is the sum of the voltage drop across this guy plus the voltage drop across this guy. And V2 is the sum of the voltage drop across this guy plus the voltage drop across this guy. So in math terms, V1 is 18 ohms times I1, because, you know, what do I write V equals IR. So the voltage across this 18 ohm resistor is given by 18 I1. The resistance times the I1 current going through this guy. Plus, oh, well, V1 is the sum of those, the voltage drop across this guy and the voltage drop across this guy. So it's 3 times 3I. Okay, and V2 is likewise, it's the voltage drop across the 6 ohm due to the I2 current, plus the voltage drop across the 3 ohm resistor due to the I1 current. So it's 6I2, right? That's the voltage drop across here because I2 is going through this guy, plus the voltage drop across this because due to I1, so it's 3I1 again, or 3I, sorry. Might have misspoke a couple of times in there. I hope that doesn't throw you off too much. But anyway, these are known values. So this is 18 times I1 is what? 2, and I is 3, right? And this is 6, and I2 is also 2, just coincidentally. And so this one works out to be 24 volts, and this one works out to be 48 volts. So that's the answer for V1 and V2, what they're asking us to find. All right. So let's see, what can I, let me just summarize the problem here. We started off with this. We've got a delta between A, B, and C. We break that into a Y. there's these original voltages, V1 and V2, in the delta configuration. They're still present in the Y configuration because V1 is between A and C, V2 is between B and C. But even though here there's one resistor between AC, now there's two resistors between AC, and likewise here there's one resistor between BC, but now there's two resistors between BC. But there's still V1 and V2 because V1 and V2 are measured between the nodes, really. Okay. So you do that, and then you could do a bunch more series and parallel simplifications. You end up with this simple guy who lets you do A1, or lets you do I, rather, lets you find I. And then the fun part is realizing that this I current, which is coming out of the original source, right? We found it here with the single resistor equivalent, but it still applies to here because it's coming out of the source. But back on the original circuit, well, really this one, you know, this I splits, and you can use this fancier form of current division to get those guys, and then you can find the individual drops across the resistors to find this. So it's a fun problem because, you know, you're sort of transforming this halfway and then, you know, using the circuit at that point and to get some stuff, but then, you know, you can transform it some more and get some other stuff. It's a really good problem about what changes and what stays the same, right? This I, it stays the same because it's all the way back to the source. It's coming out. But in here, the V's are lost, right? In this final transformation, the V1 and V2 are gone. You can't find them in there, right? But I is still good, right? Likewise here, after this transformation, the V's are still good. And they disappear here, but they're good here. Okay, it's good stuff. It's a little bit confusing, but work this and, you know, study it. It's good stuff. All right. Thanks. Bye.